Okay, today we are discussing Venn diagrams, and Venn diagrams, are familiar with them, is a diagram that shows a relationship between sets. So if A is one set and B is another set, how do they overlap? Do they overlap? And that kind of thing. So this is also dealing with the notation and things like that. So for this one, we just want A. So shade set A. So if I shade set A, that's this. That's it. And my awesome coloring jobs is there. So that's shows you A. The next one here, shade A and B. So where do both A and B intersect? So if this is A here, this is B, they intersect right here. So intersecting here, as best as I can do, that's A intersect B. So this is the set notation right here for intersection, or for the word and. It's another way to say and is this is intersect and this little symbol that looks like a upside down U. Shade A or B. So we have A here. Whoa, sorry. I'd lost my highlighter. We have A here, B here. Now they overlap. Now we dealt with this yesterday a bit. They overlap, but they overlap in the same spot. So A or B is both of those put together. So or is the same thing as union, which is this little U. And often when we think or, we think adding. Okay, shade not in set A. So everything not in set A. So not in set A would be all the stuff. I'm going to outline first because that's what I like to do. There we go. And done. So everything not in A is that. Beautiful. So A not is the same thing as the complement, or this little prime thing, and that's the notation. All the points not in set A. I like this highlighter. It's highlighting. All right, next one. Shade not in A and B. So we look at what both A and B would be here, but that's not, so it's everything but there. So this is the not part. So what we want to do is basically, here, I'm going to color everything. Let me make this bigger so that it's quicker. Okay, but since I want to take out that little section, not my best work, but, well, it probably is my best work knowing me. So that's not in A and B. Shade not in A or B. Okay, so we know A or B would be, so if you look at this one right up here, this is A or B, so everything not in it, so everything else. So all this stuff outside. Now, I'm going out of the bounds here, but we assume that it's in a box, so that's all the people. That's like the set. So it's not everything in the whole world, it's just out of this group of people or group of things. All right, this is the exact same thing, but we're doing probability. So it's the exact same thing when you deal with probability and when you deal with sets, the notations and things like that. So just take a second and try to do these, and I'll come back with the answers. Okay, so A or B would be this. Now it's still the probability of A or the probability of B. It's the same thing as what the two sets look like together. So the complement of B, or not B, what's that probability? Well, it's all of these but B. B is the only thing that isn't showing. Both A and B, that's where they intersect. This is A or B. This is like the very last one at the top. This is A or B, so then the complement of it would be everything outside there. This one's interesting. These last two are interesting because you have A or B, that's this whole thing, like we had right here, this right here, and here. This is or. But we want to subtract where they're the same, so we want to get rid of this. This is actually called the exclusive or. So it excludes anything that's in between, that's intersecting with them. And then this particular one is A and the complement of B. So it's basically anything that's in A, but not what's in B. So it cuts out whatever's in B, and there we are. So how do we use this? Well, we use this to create our Venn diagrams and figure out probabilities and different possibilities. Okay, so out of 40 students, so we know in our little set here, there are 40 students. 14 take English and 29 are taking chemistry. So we have English and chemistry. So here's English and chem. I should probably use different colors, but whatever. We want to be able to fill in this right here. So we have a total of 40. How many? Okay, this really isn't enough information. So let me look at part A. If 5 students are in both classes, so 5 of them are taking both classes. That makes this easier. 5 are taking both classes, so if English, this whole English right here, are taking 14, we already have 5 of them right here. There's already 5. So how many left to make this circle 14? Well, that's 9, because 9 plus 5 is 14. Okay, so and this one in chemistry, 29 are taking chemistry here. So then this should be 24, because 24 plus 5 is 29. So add these all together. 38. So that's a 38 total. So we can say that 2 of them are not taking the class. So how many students are in neither class or neither class? That would be 2. How many students are in either class? So that means are taking either class. So there's 38. That's the or. There could be either in English or chemistry. So that's 38 total. If we add all these 3 together, we get 38 total. So what is the probability that a randomly chosen student from this group is taking only chemistry? Well, only chemistry here is 24, because this one, these 5 people here are also taking English. So there's 24. Whatever. Sorry. 24 out of 40. Okay, so the next one. This one is a little bit more tricky because there's 3 things involved. So in this case, if we read this over, there are 79. So this is a total of 79. All of these, they're a combination of math. So we're going to say this is math. Make this geography. And then this one is history. It doesn't matter how you do that, it's just the way it is. So we're taking these people, all of them are taking this. There's no people that aren't. Okay, but I still like to put the box around it. So there's all of these added together is going to be 79. So the things that they give us is people taking geography is 41. So geography is 41. That's the total that's going to go in there. But I don't know how much are in these little spots. So no, this little spot here is all taking all 3 classes. This little spot here is math and geography. And this little spot is math and history. And this little spot is geography and history. Okay, so what you need to do is try to create this. So there's lots of information that they give us and nothing is useful just yet. So the next thing I see is history. There's 36 that are going to be in that total. And math is going to be 30. If you add those all together, it's way over 79. So you know that some things have to overlap. So then we have extra information here. Both geography and history is 6. So what that means is geography and history, that's these 2. So this right here is going to be 6. And this right here, this one and this one, is going to be 8. No, 16. Okay, so here we go. So what we have to do is kind of go, they're going to tell us who takes what only. So 8 people take only math, so I know that's going to go there. 16 people take only history. Okay, so far so good. So how can I fill in the rest of these? So maybe you can take a minute and see if you can do it, because this is going to take me a while to explain this piece by piece. So I'm going to take it and fill it in for you, and we'll come back. So try it out. Okay, so this is what this looks like, or this should look like in the end. We have 16 total taking math and history, 6 total here doing both geography and history, 2 total taking all 3. And these are 8. So we'll do this a little bit more in class if you can't figure that out. But the basic idea is, now that we have this, what is the probability that a person takes math and geography? So math and geography, that's 6, but not history. So that would be 6 out of 79, because that's the total. Takes geography only. So we got 29 on that. So 29 out of 79 takes all 3 subjects. All 3 subjects, so that's only 2 out of 79. So once you have the Venn diagram, it's pretty straightforward. This one's somewhat complicated, but fun.